We picture the birth of our universe, the Big Bang, an infinitely dense point erupting 13.8 billion years ago, unleashing space, time, matter, and energy in an epic expansion that continues today. It's a powerful image, supported by vast amounts of astronomical observation. And according to Einstein's foundational theory of general relativity, this event wasn't just the start of everything in the universe. It was the start of the universe's framework itself, space-time. General relativity beautifully describes gravity as the curvature of this four-dimensional space-time fabric. Time isn't separate from space. They are interwoven. If you trace this fabric back using Einstein's equations, you reach a point of infinite curvature, infinite density, the initial singularity. In this classical view, space-time begins there, so asking what happened before becomes a logically ill-posed question within that framework. Much like asking, what direction is north of the North Pole? Time, as described by relativity, simply doesn't exist prior to that point. But pause for a moment. Does that truly sit right? Our deepest intuitions about reality are rooted in cause and effect. For something to happen, doesn't something need to precede it? Can an entire cosmos, with all its intricate laws and structures, truly emerge uncaused from absolute non-existence? Not just absence of matter, but absence of space, absence of laws, absence even of time itself, the very possibility for change? Modern physics doesn't propose creation from absolute nothing. Ideas about the universe's origin often involve concepts like quantum fluctuations in a pre-existing field, or the universe bouncing back from a previous collapse. But here's the crux. For any of these processes to occur, for a field to fluctuate, for brains to collide, for a universe to bounce, there must be some concept of sequence, of dynamics. There must be a before the fluctuation and an after, a before the collision and an after. This inherently requires something that functions like time. This leads us to a profound idea, the possibility of a primordial time, a form of time, or at least a dynamic principle, that existed before our familiar space-time came into being with the Big Bang. This wouldn't necessarily be the time we measure with clocks, inextricably linked to the expanding space of our universe. It could be something more fundamental, existing in whatever state or reality preceded our own cosmic dawn. Now, how does this fit with general relativity seemingly saying time began at the Big Bang? We must remember a critical point. General relativity, while incredibly successful, is known to be incomplete. It famously breaks down at the quantum scale, and most importantly, right at the singularity it predicts for the universe's beginning. A theory cannot be considered the final word precisely where it itself predicts its own failure. We shouldn't treat the boundary conditions of an incomplete theory, like time beginning precisely at the singularity, as unbreakable laws of reality. The singularity signals not necessarily an absolute beginning, but the edge of our current understanding, the point where a deeper theory, likely incorporating quantum mechanics, a theory of quantum gravity, must take over. Perhaps even a necessity for a pre-Big Bang phase. Whether that phase involved a quantum vacuum state humming with potential fluctuations, a previous universe cycle, or existed within a larger multiverse structure, it needed a framework for change. It needed this primordial time. What might this primordial time have been like? Speculation runs wild, of course. It might not have had a single, linear direction like our time. Perhaps it was multidimensional, or emerged discontinuously at the quantum level. Maybe its flow was governed by entirely different principles. We lack the data to know for sure, but its essential characteristic would be enabling dynamics, allowing the state before our universe to evolve, change, and ultimately trigger the Big Bang that gave birth to the space-time we inhabit. So while the familiar river of time flowing through our expanding space likely began its course 13.8 billion years ago, the evidence of causality itself strongly suggests it wasn't the first drop. The logic demands that some dynamic principle, some form of primordial time, must have existed in the ultimate precursor state, making the birth of our universe possible. Let's talk about the very beginning. Not just the early universe, but the actual moment of creation, the Big Bang singularity. It's an idea that defies comprehension. How could everything, all the matter, all the energy, all the space we see today, have originated from a single point? How did that point even hold it all? And where did it come from? Could there be an even stranger origin story, one that connects our universe to others, perhaps through the most extreme objects we know? First, let's tackle that singularity. When physicists use Einstein's theory of general relativity to describe the expanding universe and run the clock backwards, everything converges to a point of zero size and infinite density. That's the singularity. But it's probably not quite right to think of it as a tiny container holding everything. It's more accurate to say it was the state from which space itself began to expand. The concepts of size and volume break down there. But here's the crucial part. Most physicists don't believe this mathematical infinity is physically real. It's seen as a sign that general relativity, our theory of gravity, is incomplete. It doesn't include quantum mechanics, which is essential at such tiny scales and extreme energies. The singularity might actually be a tiny but finite region governed by quantum rules we don't yet fully grasp, not an actual point of infinite density. Now, what about the idea that the universe came from nothing? This gets tossed around a lot. In physics, nothing usually isn't absolute emptiness. One idea is based on quantum physics. Even a vacuum isn't truly empty. It's a sea of quantum fields fluctuating. Some theories propose our universe could have started as a random quantum fluctuation within such a field, a bubble of space-time popping into existence. Another related idea is that the universe's total energy might be zero, the positive energy of matter perfectly balanced by the negative energy of gravity. If the net energy is zero, creating it doesn't necessarily violate energy conservation laws. So coming from nothing in physics often means emerging from a pre-existing quantum state, or a state of zero total energy, not necessarily from absolute non-existence. But there's another, even more mind-bending possibility. What if our Big Bang wasn't the ultimate beginning? What if it was connected to something else? Something like a black hole. This is a speculative but fascinating hypothesis. We think black holes also contain singularities where general relativity breaks down. What if quantum gravity effects prevent true infinite collapse inside a black hole? What if instead the incredibly compressed matter and energy bounce? Imagine matter falling into a black hole in a parent universe. It collapses towards the center, quantum gravity steps in, prevents total oblivion, and triggers a rebound. This rebound could forcefully expand a new region of space-time. From the perspective of this new emerging universe, this event might look like a white hole, the time-reversed opposite of a black hole, spewing out matter and energy. This idea, sometimes called black hole cosmology, is tantalizing. It potentially solves the "where did the singularity come from" question by linking it to a physical process in a prior spacetime. It connects cosmology to black hole physics through the lens of quantum gravity. However, let's be really clear. This is still a speculative hypothesis. It's an active area of theoretical research, but it's not part of the standard confirmed model of cosmology. We don't have direct evidence that our universe was born this way. It's one possible answer generated by pushing our theories to their limits. So the singularity at the beginning remains a profound mystery, likely pointing towards the need for new, unified physics. The idea of an origin from nothing is more complex than it sounds, and the possibility that our entire cosmos is the offspring of a black hole in another dimension, or parent universe. That remains one of the most thought-provoking, though unproven, ideas at the frontiers of science. It shows us that the quest to understand our origins forces us to confront the nature of space, time, infinity, and potentially entire other universes. What do you think? Could our universe have emerged from a black hole? Does the idea of an origin from nothing make sense to you? Share your thoughts below. Subscribe for more explorations into science and philosophy. Thanks for watching, and see you in the next one.